Hello everyone, today we are going through nature of roots of a quadratic equation. So first of all, let's write the standard form of quadratic equation. Ax square plus bx plus c is equal to 0. And we know that how to find the roots of a quadratic equation using quadratic formula, that is x is equal to minus b plus or minus square root of b square minus 4ac divided by 2b. Okay. Here b square minus 4ac is called discriminant. So here in this discriminant, using discriminant we can find the nature of roots of a given quadratic equation. That is, first case, if b square minus 4ac is less than 0, okay, if you get b square minus 4ac less than 0, then given quadratic equation has no real roots. That is, suppose b square minus 4ac is equal to minus 6. Less than 0 means minus value, right? If b square minus 4ac is equal to minus 6, then here it will be square root of minus 6. Is it a real number? No. It's an imaginary number, right? That is, we know that square root of minus 1 is equal to I, an imaginary number. It's not a real number, right? Therefore, if b square minus 4ac is less than 0, then given quadratic equation has no real roots. Okay? So, it is the first case. In second case, if b square minus 4ac is equal to 0, then you will get only one root. That is real. You will get only one root. So remember, if b square minus 4ac is equal to 0, then given quadratic equation has only one real root. And if b square minus 4ac is greater than 0, you will get distinct two roots. Okay, two distinct roots. That is real. So remember, if b square minus 4ac less than 0, then given quadratic equation has no real roots. If b square minus 4ac is equal to 0, then equation has only one real root. And if b square minus 4ac greater than 0, then equation has two real distinct roots. Okay. Look at an example. Now here let's check what is the nature of roots of this quadratic equation. Okay. Here, so first of all, let's find the roots. See here, first of all, to find the nature of roots, here we will find b square minus 4ac. Okay, b square minus 4ac. So here what is a? A is equal to 2, b is equal to minus 4, c is equal to 3. Right? So b square minus 4ac is equal to minus 4 square 16 minus 4 into a is 2 into c 3. Okay. Now that is equal to 16 minus 4 into 3, 12, 12 2s are 24, that is equal to minus 8. See, here we have got b square minus 4ac less than 0. Minus 8 is less than 0. Therefore, here we can say the quadratic equation 2x square minus 4x plus 3 is equal to 0 has no real roots. Here we will get the roots, but it will be an imaginary, a complex roots. Okay, you will study in 11th standard complex numbers. So here we can say this quadratic equation has no real roots. First question, check whether the given quadratic equation has real roots, and if so, find the roots. Quadratic equation is given 3x square minus 2x plus 1 by 3 is equal to 0. So here first of all we have to check whether this given quadratic equation has real roots or not. We know that how to determine the nature of roots of the given quadratic equation, right? That is, so first of all, find the discriminant. That is, b square minus 4ac. So here let's write what are a and b, a, b and c values. A is equal to 3, b is equal to minus 2, c is equal to 1 by 3. Okay, next let's substitute. B square, that is 4, minus 4 into a 3 into c 1 by 3. Okay, 3 cancelled here, that is 4 minus 4 0. Okay, now here we have got b square minus 4ac is equal to 0. So here we know that if discriminant b square minus 4ac is equal to 0, then the quadratic equation has only one real root. Okay, so it has root, okay, only one root. Now let's find it. That is x is equal to minus b plus or minus root of b square minus 4ac divided by 2a. It is the formula to find the roots of the quadratic equation. So here minus b, that is minus b minus of minus 2, that is 2, plus or minus 0. We have already found b square minus 4ac, that is 0. Square root of 0, 0 itself. So divided by 2 into 3, that is 6. That is equal to 2 divided by 6, that is 1 by 3. So 1 by 3 is the root of given quadratic equation. Look at this question. The roots of the quadratic equation x square plus x minus 1 is equal to 0 are options: irrational and distinct, not real, rational and distinct, real and equal. So see, here it is the question, CBSE 2024 question. So first of all, let's find discriminant b square minus 4ac. Okay. So first of all, let's write the equation x square plus x minus 1 is equal to 0. Here a is equal to 1, b is equal to 1, c is equal to minus 1. A is the coefficient of x square, b is coefficient of x, c is the constant term. Okay. Now let's find b square minus 4ac. Okay. That is equal to b square 1 square minus 4 into a into c. That is equal to 1 minus 4 into 1 4, 4 into minus 1 minus 4. So minus of minus 4 plus 4. That is equal to 5 greater than 0. Okay. So here we have got b square minus 4ac greater than 0. Now therefore given quadratic equation has real roots and distinct. That we have to find, because it is not the answer, right? And it is not the answer because we have got b square minus 4ac greater than 0. Therefore it has real roots and distinct. Okay. Now let's find rational or irrational. Okay. So here x is equal to minus b plus or minus root of b square minus 4ac divided by 2a. That is equal to minus b. B is 1, so minus 1 plus or minus root 5. We have already found b square minus 4ac divided by 2 into a, that is 2. See, here we know that root 5 is an irrational number, right? Therefore, here what are the roots? X is equal to minus 1 plus root 5 divided by 2 and x is equal to minus 1 minus root 5 divided by 2. These are the roots. Okay. So here we have got an irrational roots. Okay. And distinct. Okay. So here it is the correct answer, because root 5 is an irrational number. Therefore these roots are irrational. Find the value of p for which quadratic equation px into x minus 2 plus 6 is equal to 0 has two equal real roots. CBSE 2023 question. Here we have to find the value of p, and it is given that given equation, quadratic equation has two equal real roots. Means it has only one root that is real. Okay. And we know that if b square minus 4ac is equal to 0, then given equation has only one root, real root, right? So first of all, let's write the given equation. Px into x minus 2 plus 6 is equal to 0. See, first of all, we have to write the given equation in the standard form of quadratic equation. Okay. After that, you will find the roots or discriminant. Okay. So px, so let's make it in the standard form. That is px square minus 2px plus 6 is equal to 0. See, ax square plus bx plus c is equal to 0. Now here we will write AB's values of A, B and C. A is equal to P, B is equal to minus 2P, C is equal to 6. Okay. And it is given that given equation, quadratic equation has two equal real roots. Means given a quadratic equation has only one root, that is real. Therefore, discriminant b square minus 4ac is equal to 0. Okay. Since given equation has two equal real roots. Two equal real roots means there is only one root, that is real. Okay. Real roots, b square minus 4ac is equal to 0. Okay. Now, what is b square minus 4ac? b is minus 2p, b square is 4p square minus 4 into a into c. That is 6. Okay. So that is equal to 0. That implies 4p square minus 24p is equal to 0. Here p is common, right? So let's take it out. P into 4p minus 24 is equal to 0. Okay. So p into 4p minus 24 is equal to 0. That implies, see, here we know that if a into b is equal to 0, that implies either a is equal to 0 or b is equal to 0. Right? Either a is equal to 0 or b is equal to 0. Okay? Or a and b both are 0. Okay? So here we can say p is equal to 0 or 4p minus 24 is equal to 0. Right? Either p is equal to 0 or 4p minus 24 is equal to 0. That implies p is equal to 0 or p is equal to 4p is equal to 24, p is equal to 24 by 4, that is 6. So value of p is 0 or 6. Find the discriminant of the quadratic equation 4x square minus 5 is equal to 0. And hence comment on the nature of roots of the equation. So here we don't need to find the roots of the equation. Here we have to determine the nature of roots of the equation. Okay. So here given equation is 4x square minus 5 is equal to 0. Okay. So what is the discriminant? That is b square minus 4ac, right? So here value of a is 4. What is the value of b? There is no x term, right? That is second term, that is coefficient of x is 0. b is equal to 0 and c is equal to minus 5. Right? That is a is equal to 4, b is equal to 0, c is equal to minus 5. Okay. Now let's find b square minus 4ac to find the nature of roots of the given equation. Okay, b square minus 4ac is 0 minus b square is 0 minus 4 into a is 4 into c is minus 5. That is equal to 4 into 5, 20, 20 into 4, that is 80 minus minus plus. So 80, that is greater than 0. Right? So here we have got b square minus 4ac greater than 0. Then we know that if discriminant is greater than 0, then given equation has two distinct real roots. Okay? Therefore, given equation, quadratic equation has distinct real roots. Okay, you will get different real roots. If the equation 1 plus m square x square plus 2mcx plus c square minus a square is equal to 0 has equal roots, then show that c square is equal to a square into 1 plus m square. Okay, here it is given that given equation has two equal roots, means it has only one root, that is real. Okay, we know that if an equation has only one root, then discriminant b square minus 4ac is equal to 0, right? So first of all, let's write the equation 1 plus m square x plus 2mcx plus c square minus a square is equal to 0. Okay, since this equation has only one root, that is equal roots, then b square minus 4ac is equal to 0, right? That implies here what is b? Coefficient of x 2mc, that is 2mc square is 4m square c square, minus 4 into a is 1 plus m square, c is constant term, sorry, into c, okay, into c square minus a square, that is equal to 0. This implies, see here in both terms 4 is common, we can take it out and take to right side, it will be 0, okay. So here left side m square c square. Now let's expand this one, minus 1 into c square and 1 into minus a square m square into c square m square c square plus minus m square into minus a square, that is minus m square a square, that is equal to 0. Okay, that implies take this term right side, so m square c square is equal to, okay, minus is here, let's take together, all together take to right side, okay. So here c square minus a square plus m square c square minus m square a square. See here, see m square c square is cancelled, okay. This implies here it is 0 is equal to c square minus a square minus m square a square. That implies here, see, take this one left side, so here we will get c square is equal to, take this one left side, so c square is equal to a square plus m square a square. That implies c square is equal to, a square is common, take it out, a square into 1 plus m square. It is proved.